Wisneski, presenting about the impact of salary allocation on NHL team success.
Hi everyone, thanks for coming. My name is Andrew and I'm a junior majoring in finance, and my advisor for this honors thesis was Dr. Clark, and I'm going to talk about the impact of salary allocation on NHL team success. So for a brief introduction, the NHL implemented a salary cap system that provided strict limits for how much teams could spend on their player salaries after a lockout of the 2004-05 season. So this system has been in place since 2005-2006, so this is next season will be the 10th year of it. The goal of the system is to increase competitive balance among teams and also financial equality. The teams, however, are allowed to allocate their player salaries differently within this cap, so that was what I really wanted to look into. But I've noticed that some teams seem to be successful every year. If you look across the bottom of the screen here, 2010 and 2013 the Blackhawks won the Stanley Cup, 2012 and 14 the Kings won the Stanley Cup. So in the past 5 seasons, only 3 teams have won the cup and 2 of each won it twice. So a major result of this cap has been an increased importance on general managers' decisions. So the purpose of this study is to see specifically how player salary allocation impacts success. For a brief review of literature, I looked at some studies that looked into the effectiveness of the cap in terms of competitive balance, and most found that it did increase the competitive balance among teams, although the major caution was that it's still a relatively small sample size. And as far as financial equality goes, it wasn't as conclusive as to the effectiveness of the salary cap, because some teams, like for example the New York Rangers, their owner also owns the New York Knicks, he owns Madison Square Garden, he owns the TV network Madison Square Garden, he owns Cablevision, so they're able to bring in a lot more revenue than teams like Columbus or New Jersey. And while the salary cap limits how much they can spend on their players, these teams are able to spend more on other aspects. In terms of success, I wanted to look at other studies out there that measured success in the NHL. So different measures were win percentage, total wins, looking at different X variables, the round of the playoffs the team reached, and then one interesting study I found was another one that looked at win percentage versus something called the Gini coefficient, which was a variable that the author made that measured the spending equality of the team. So were they putting their money in the right place? And just for reference here, those are the salary cap upper limits each year since the system has been in place. So my methodology, my research question was, how do decisions made by NHL general managers impact success? My model development, my dependent variable was team success, which I measured in points percentage, and you find that by taking the number of wins a team got plus the number of overtime and shootout losses divided by 2, because those only count for 1 point each, and then you divide that by the total number of games played. And this allows my variable to be on the same scale for the lockout season, where they only played 48 games, whereas every other season's 82. My independent variables were the percentage of salary cap that the team allocated to their top 5 players. So again, I used percentage for that variable because the salary cap changes every year, like you saw on the last slide. So this allows to be on the same scale. And I used Fenwick plus minus to pick the top 5 players because it's a statistic that's a newer advanced statistic that measures the number of unblocked shot attempts by a team while the player is on the ice versus the number the other team gets while the player is on the ice. And this variable puts defenders and forwards on the same scale. And certain teams, like that's the Chicago Blackhawks general manager, they've been known to use these advanced statistics, so I know it's out there. And then I also looked at coach tenure and coaching change. So that is if the coach was changed during the season. And those are just some other variables to add some strength to my model. I collected my data from third-party sites, so that's one caution in my study. I didn't collect the data firsthand, so I have to trust that their data was accurate. And I analyzed the 2009-10 through 2013-14 seasons, and I did 1 regression for each season and 1 overall model. So here you can see my results slide. I'll get a little more into the discussion afterwards, but the important things to note here are that for my overall model, the N was 150, which makes sense because it was 30 seasons, five seasons, 30 teams each. And you can just see up here, these are just some of the descriptives for the variables, and these are the regression values. As for some of the discussion, some things that stand out to me were the salary allocation mean was 23.1, which makes a lot of sense because if you think about it, 5 players out of 23 would be 21.7% of the team. So I figured the mean would be right around there, and it is. But I found it interesting that the standard deviation was 0.09, meaning that some teams are down around 10% and some are up closer to 30, 35. So there's definitely a pretty big spread in there. The highest overall in any season was Detroit, that spent 50.1% of their cap on just 5 players. And an interesting thing about Detroit is they've actually made the playoffs 24 straight years, and were consistently one of the highest teams in terms of salary allocation that I studied. So I think that was an interesting pattern. And the lowest was the Washington Capitals in 2012, when they only spent 4.9% of their cap on their top 5 players measured by the statistic. So I think it was really interesting to see the spread there. I did Durbin-Watson tests just to make sure that my variables were not autocorrelated, which would have resulted in a higher R-squared, and they were in the acceptable range. I found that coaching tenure was not statistically significant, and that coaching change, which was just a yes/no variable, was significant. And while coaching change was sort of hard to measure the actual impact, because most of the times teams make a coaching change when they're doing pretty bad and want to try to shake things up. And in most cases, the team didn't really have much success after that. But there were 2 interesting examples. In 2010, the Flyers fired their coach during the middle of the season and ended up losing in the Stanley Cup Finals. And in 2012, the Kings fired their coach and hired Daryl Sutter, and they actually won the Stanley Cup that year. So I thought those were interesting events. So overall, my main variable, salary allocation, was statistically significant. You can see the T value there in the overall model, so I was happy about that. The standardized coefficient beta of salary allocation was 0.485, which is higher than any of the other variables I studied, so that tells me that it has the most explanatory power in terms of my success variable. My overall model was significant with a p-value there, significant in the 0.05. However, my adjusted R-squared was only 0.341, so overall the model is not a very strong indicator of success, but the variables were statistically significant, so I was happy with that. The best adjusted R-squared was only 0.455 for the 2014 season, so my best model still only predicted less than 50% of the variability, but again, I was looking at the significance, so I was pretty satisfied with that. And that's the Penguins assistant general manager, Jason Botterill, who's responsible for their salary caps. He's known as being a capologist, so I think that my study shows that guys like that are important for NHL teams. So some limitations and future research. I only consider regular season success for my success variable, and I think if you ask most people around the NHL, they're going to consider success as playoff wins, Stanley Cup wins. For example, the Bruins, who have been one of the most successful teams the past 5 years, just fired their general manager just because they didn't make the playoffs this year. So I think a model that could look at playoff and Stanley Cup success would be more useful. The use of Fenwick plus minus to pick the best players was a major limitation because that statistic doesn't account for things such as ice time or the strength of the opponent or where the player starts most of his shifts. It also doesn't include goalies. So in the future, I would want to use a stat more like wins above replacement in baseball, which they sort of talked about. There's a site that I was looking at, waronice.com, that's actually in the process of developing that statistic for hockey. So I think a statistic like that would be a lot more meaningful in picking the best players. I only use 5 seasons of data, so increasing the number of seasons and therefore the end would be more significant. And I would also want to include more variables to improve the R-squared that sort of go along with the theme of decisions made by the general manager. So things would include just trades in general that the team made, the age of the players, player turnover, which would be how many players change from one year to the next, player acquisition, so were the players on the team acquired by the draft or free agency or trades, and also how many players are on an expiring contract, because I think there's sort of a theory that players might go a little harder in the year that they're up for a new contract. So I'd be interested to look into that. And that is the Rangers general manager, who's pretty well known for some of the trades he's made, so that's why I thought I'd put him up there. And overall, I think that this model showed that salary allocation is a significant variable in terms of success in the NHL. Overall, the strength of comparing this overall to success wasn't too strong, but it was definitely a very interesting look, and I'll be interested to do some more research on this in the future. So thank you for coming out today, and that's all I have for now.